Okay, what's up everybody? This is KJ. Welcome back to the deli. Stop by, get yourself a macaroni and cheese sandwich on grilled Wonder Bread. I got you, Alex. Okay, so for the first one, we have a few ASN problems. If two sides and one angle of triangle A are congruent to two sides and one angle of triangle B, then triangle A is congruent to triangle B. That would be sometimes, and the reason, let me draw some triangles. We could have that. This would work because you could prove them by SAS, and then you could have another one that wouldn't work. You could have, say, something like that, and that wouldn't work. So that's what sometimes. The second one, if two sides and the included angle of triangle A are congruent to two sides and the included angle of triangle B, then triangle A is congruent to triangle B. That would be always, because you have the two sides of the triangles that are congruent, and the included angle is the angle that's in between the two sides of the triangles, so that would be always. And then the last one, the HL theorem, is the example of when ASS works. That would be always, because you have your right angle, then you have your hypotenuse and another leg, A, S, S.
I'm going to change your slide now.
Okay. Okay, so number one, solve for x of the picture above. These two sides are congruent, so you can say x squared minus 6x equals 55. Move the 55 over, equal to 0. Then we have the two numbers. You have negative 11 and positive 5. So then you have x equals 11 and x equals negative 5. So that's your answer to part 1. Then given triangle nu is congruent to triangle car. So let me draw some pictures.
Scroll down and need more room.
Okay. So EN is equal to 11, AR 2x minus 4y, and WX plus y, CA 4x plus y, and EW is equal to 10. We need to solve for CR. So what I did was I set 11 from NE equal to 4x plus y, and then subtract 4x from both sides. You get y equals 11 minus 4x, and then plug that in.
More room, okay?
Okay.
Is that alright?
Yeah.
Okay.
So then 10 equals 2x minus 4y, and then plug this in for y, so 10 equals 2x minus 4 times 11 minus 4x. 10 2x minus 44 plus 16x. You get 54 equals 18x, and then 3 equals x. And then you can, let's see, yeah. Okay, so then I have 10 equals 2x minus 4y, and since x equals 3, 10 equals 2 times 3 minus 4y. So 10 equals 6 minus 4y. 4 equals negative 4y. So divide everything by negative 4. You get negative 1 equals y. And then since the two triangles are congruent, okay. Since the two triangles are congruent, you plug in x, which is 3, and y, which is negative 1. 3 plus negative 1 equals 2, so that means CR equals 2. Okay, so okay. Okay, so we let me list the givens. We have AC is congruent to BC, and angle 1 is congruent to angle 3. That's given. So then from there I said angle CAB is congruent to angle CBA, and that would be if sides, then angles. And from there we can say that CD is congruent to CE, and that would be if angles then sides. Then from there, DA is congruent to EB, and then you can say that by segment subtraction. And then AB is congruent to AB by reflexive. So then we can say triangle DAB is congruent to triangle EBA, and that would be SAS. Then we can say angle ADB is congruent to angle BEA, and the reason would be CPCTC. Mr. Yulin, do I just click the down arrow for... And then the next thing we can say is angle EGF is congruent to angle DEF. Lost my picture, but that's okay. Then that would be angle subtraction. And then GF is congruent to FE. That would be if angles, then sides. And then final thing would be triangle DFE is isosceles. And then the reason would be definition of isosceles. Boom!